Far beyond the bright worlds that circle our sun, there is a region where sunlight loses much of its strength and becomes little more than a distant glow. In that immense darkness, Voyager 1 continues moving outward, farther than any human-made object has ever traveled. The spacecraft is no longer exploring planets or moons. Those familiar landmarks were left behind long ago. Instead, it now journeys through a vast expanse where the nearest destinations are measured not in millions of kilometers, but in distances so enormous that they challenge ordinary imagination. When Voyager 1 launched in 1977, its mission was never intended to last this long. Engineers built it to investigate the outer planets and gather information during a relatively short scientific expedition. At the time, its technology was considered advanced, yet by modern standards it was remarkably simple. Few people imagined that decades later the same spacecraft would still be operating, transmitting data from a realm no probe had ever explored before. As Voyager traveled beyond the giant planets, scientists began realizing that the edge of the solar system was far more complex than previously believed. For many years, the outer boundary of the Sun's influence was viewed as a relatively straightforward transition into empty space. The expectation was that once the spacecraft crossed this frontier, the environment would become quieter and less active. The reality turned out to be very different. Over time, Voyager's signals occasionally became difficult to interpret. Information arriving at Earth sometimes appeared incomplete or distorted. Engineers worried that the effects of age, radiation, and extreme distance were finally overwhelming the spacecraft. Since commands required many hours to reach Voyager and responses required equally long periods to return, even simple troubleshooting became a slow and delicate process. There were moments when communication seemed dangerously close to failure. Yet each time, patient analysis revealed that Voyager was still functioning. Beneath the noise and interference, valuable scientific observations continued flowing back toward Earth. One of the most important milestones occurred when Voyager entered interstellar space. This was not merely a symbolic achievement. It marked the spacecraft's passage beyond the protective bubble generated by the Sun. On one side existed the solar wind, a continuous stream of particles flowing outward from our star. On the other side stretched an environment shaped by the wider galaxy itself. Scientists expected this region to be relatively uneventful. Instead, Voyager discovered an active and surprisingly structured environment. Its instruments detected changes in plasma density that rose and fell in distinct patterns. These variations were not random. They appeared to be evidence of powerful disturbances moving through space, some likely originating from ancient stellar explosions that occurred long before human civilization existed. The energy released by those distant events was still influencing the interstellar medium across vast stretches of the galaxy. Magnetic field measurements revealed additional surprises. Rather than finding a uniform environment, Voyager encountered regions with noticeably different magnetic characteristics. Some areas displayed orderly structures, while others showed signs of turbulence and instability. These observations suggested that interstellar space contains boundaries, layers, and large-scale formations created by processes operating over millions of years. The deeper Voyager traveled, the clearer it became that space between the stars is not an empty void. It is a dynamic environment filled with particles, fields, and invisible interactions occurring on enormous scales. Radiation levels also changed dramatically after the spacecraft crossed beyond the Sun's direct influence. High-energy particles became more common, exposing Voyager to conditions unlike those experienced within the solar system. Each new measurement provided scientists with valuable clues about the broader galactic environment surrounding our cosmic neighborhood. As the mission continued, age began affecting some of the spacecraft's systems. Engineers eventually identified problems associated with onboard memory and data processing components. Repairing hardware located billions of kilometers away seemed almost impossible. Nevertheless, mission teams developed creative solutions, sending carefully designed commands across deep space in an effort to restore functionality. The process required extraordinary patience. Every instruction traveled for many hours before reaching the spacecraft. The response then required the same amount of time to return. Yet despite these challenges, engineers succeeded in recovering important systems and extending the mission far beyond expectations. With improved performance, Voyager resumed providing valuable scientific information. Researchers began identifying evidence of distinct interstellar regions with differing properties. Variations in density, temperature, and magnetic behavior suggested that the spacecraft was moving through separate zones within a larger galactic environment. Some scientists compared these phenomena to a form of cosmic weather. Invisible currents appeared to flow through space. Magnetic structures shifted and interacted. Energetic disturbances traveled across vast distances, much like storms moving through an ocean. Although entirely, as Voyager 1 moved farther into interstellar space, a remarkable realization began to emerge. The spacecraft was no longer simply crossing distance. It was crossing time. Every signal arriving on Earth carried information from nearly a full day in the past. Scientists were not observing Voyager as it existed in the present moment. They were seeing a delayed snapshot of a machine operating billions of kilometers away in an environment no human being could directly experience. The farther Voyager traveled, the more isolated it became. There are no repair stations in deep space, no nearby spacecraft to assist it, and no possibility of rescue. Every system still functioning today relies on hardware designed during the 1970s. Components that were never expected to survive this long continue operating under conditions more extreme than their creators imagined. Yet despite its age, Voyager remains one of humanity's most valuable scientific instruments. Its measurements have revealed that the space between stars contains far more matter than earlier models predicted. Tiny particles drift through the galaxy, forming enormous clouds that stretch across light years. Although these clouds appear thin by earthly standards, they influence the movement of magnetic fields, cosmic rays, and even the evolution of future star systems. Voyager's observations helped scientists understand that our solar system is constantly moving through this galactic environment. The Sun is not stationary. It travels around the center of the Milky Way at incredible speed, carrying every planet along with it. As a result, the solar system continuously encounters new regions of interstellar space. This means the environment surrounding our cosmic neighborhood changes over time. Some regions contain denser concentrations of gas and dust. Others are more diffuse. Certain areas possess stronger magnetic fields, while others appear relatively calm. Voyager's journey is providing the first direct evidence of these differences. Researchers believe these variations may affect how cosmic radiation enters the solar system. Understanding this process is important because high-energy particles can influence spacecraft, technology, and future missions traveling beyond the protective influence of the Sun. Perhaps the most astonishing aspect of Voyager's mission is how little of the journey has actually been completed. Although it has traveled farther than any human-made object in history, it remains extremely close to home when measured against the scale of the galaxy. If the Milky Way were reduced to the size of Earth, Voyager's distance from the Sun would represent only a tiny fraction of a single step. The nearest star system remains unimaginably far away. Even moving at tens of thousands of kilometers per hour, Voyager would require tens of thousands of years to approach another star. It is traveling rapidly by human standards but slowly compared to the enormous distances that separate stellar systems. This perspective highlights the true scale of the universe. The stars visible in the night sky may appear close together, yet vast oceans of space exist between them. Voyager is now exploring a portion of that immense frontier directly, providing humanity with its first continuous look into the environment that fills the galaxy. As scientists analyze its data, new questions continue to emerge. How do magnetic fields evolve over millions of years? What shapes the boundaries between interstellar clouds? How do ancient supernova explosions influence regions located hundreds of light-years away? Each answer seems to reveal even larger mysteries. Meanwhile, Voyager continues following a path determined decades ago. It has no awareness of its accomplishments. It does not know that generations of scientists have devoted their careers to interpreting its measurements. It does not know that millions of people across the world view it as one of humanity's greatest achievements. It simply continues moving forward. One day, its final instrument will fall silent. The steady stream of information that has connected Earth to the outer frontier for decades will come to an end. Mission Control will send commands that receive no reply. For the first time since launch, Voyager will travel completely alone. But its journey will not stop. The spacecraft will continue orbiting the center of the Milky Way alongside countless stars. It may drift through interstellar clouds, pass near distant stellar systems, and witness cosmic events occurring long after human civilization has transformed beyond recognition. For millions of years, it will remain a silent traveler carrying evidence that a technological species once emerged on a small world orbiting an ordinary star. And perhaps that is Voyager's most enduring legacy. It represents a desire that exists in every generation. The urge to move beyond known horizons and discover what lies beyond them. The spacecraft has shown that every frontier hides another frontier beyond it. Every boundary reveals a larger landscape waiting to be explored. And every step into the unknown expands humanity's understanding of its place within the universe. Somewhere in the darkness between the stars, Voyager 1 continues that journey today, moving steadily outward into a future that no one can fully predict, carrying with it one small piece of Earth into